Assalamu alaikum respected judges and welcome to our poster presentation. My name is Hasan Rhydwan and I'm going to discuss different aspects of our research work, design of a polymer-based on-screen temperature sensor. In this work, we developed a novel on-screen thin polymer-based temperature sensor. The conductor model of the sensor has been designed using graphite and copper. The sensor can detect the temperature of a human body when attached to the skin, and the use of the thin polymer makes it cost efficient. These can be easily fabricated and integrated as a smart biological data collection sensor. This work also presents a detailed simulation of the sensor to evaluate its efficiency and performance. The methodology followed in this research can be also used to develop different biomedical sensors using other novel materials. The objectives of this research were to develop and evaluate the performance of a paper-based on-screen wearable temperature sensor, develop a conductor model using graphite, investigate different characteristics of the temperature sensor, for example, stress response, temperature effect, and isothermal contour. In order to complete the manufacturing, three different types of ink will be used by the printing machine. Then it will print the targeted circuit design on the paper substrate. As a result, a printed version of the temperature sensor can be obtained. Also, multiphysics software was used to carry out the simulation of the developed model. We designed the 3D model of the sensor in the software while keeping in mind about the fact of its physical measurements. The material used for the development of the sensors model was graphite, silicon, and copper. Two different laws, including Weizmann-Franz law and Fourier's law, were used while developing the sensor. In Figure 8, the isometric view of the three stages for drawing or printing the temperature sensor has been shown. As shown in the figure, the graphite conductor wire is printed on the thin polymer in the first stage. In the next stage, the silicon-based structure is printed on the space between the graphite conduction line. In the third stage, the copper block structure is printed on the silicon base. The model was developed using different parameters for a paper-based device that includes size, lengths, and material density per area as well. The model was designed with a targeted material with precise measurement and was also divided into small blocks of cells to generate its mesh view for conducting simulation analysis that can be seen in the figure 9. On the other hand, table 1 shows different properties of the graphite conductor at 3.5 volt terminal voltage. Now I'm going to discuss about the obtained results from our research. In figure 10, the resultant effect after the potential difference was applied across the graphite conductor model can be observed in terms of voltage unit. We can see that high potential in red and low potential in blue. In the next figure, the stress response of the temperature sensor can be seen. We can see various stress points in the unit rate of Newton per meter square. In figure 12, the potential effect of the temperature sensor can be seen after a 3.5 volt was applied across the temperature sensor. We can see the positive pole and ground pole of the temperature sensor marked in red and blue respectively. The temperature effect of the surface of the sensor can be seen in the figure 13. In the conclusion section of the poster, we can see a graph of comparison between the results of an existing temperature sensor and the developed sensor in terms of temperature versus voltage. As we can see, being a polymer-based device, the developed sensor is showing an efficient result. The polymer-based temperature sensor was designed with a goal to produce an eco-friendly wearable biomedical device that could be produced at a very low cost. The sensor showed excellent results in simulation and performs better than most of the sensors available in the market. The development of such device can serve a wide range of purpose, and we can finally say that development of such device can contribute significantly in the biomedical sector. Thank you all for attending our presentation. Stay well.